In this video, we're going to continue with some more examples of how to use Z scores, which of course apply to the normal distribution. Okay. So here's example 1. In the USA, the mean ice cream consumption per year is 5 gallons. That's kind of per person, with a standard deviation of 1¼ gallons. Okay, what portion of the population consumes between 4 and 7 gallons annually? Okay, so to set this up, we'll sketch out a curve like we were doing the other day to think about what's happening here. Okay, so our mean was 5 gallons, so it'll be right down the center of the bell curve. Okay, and I want to know what proportion consumes between 4 gallons. So again, 1.25 standard deviation. So this is a little less at 4. Okay, and a bit more at 7. So maybe over here somewhere. Okay, so how am I going to figure this out? Okay, well, the key thing to note here, right, when we go to our Z-score table and look up a proportion, right, if I go into the table and get the corresponding percentile for 4, that will give me everything below 4. Okay, and similarly, if I get 7, that would get me everything below 7, including this piece over here. So if I want to go between 4 and 7, I'll just get both scores, right, 4 and below, 7 and below, and then once I've calculated that, I'll just take their difference, and that should give me the space in between from here to here. Okay, so we'll go through each one. So my first Z score, I'll call that Z1, okay, is going to start with the 4 gallon one. So I have 4 minus 5 over the standard deviation, which is 1¼ So let's see, that is -1 over 1¼ So okay, that's -0.8. Okay, and if I go to my Z-score table to look up the corresponding percentile, see we're in the negatives now. So -0.8 is 0.2119. Okay, and now I'll do the same thing for 7. So Z-score number 2 equals, we'll do 7 minus 5 over 1¼ So that would be 2. Okay, so that should be 1.6. Okay, and we'll go back to the Z-score table and look up 1.6. So that is 0.9452. Okay, and now I'll just take our larger percent, right? So I had 0.9452, and I'm going to subtract 0.2119. And I get 0.7333. Okay, so it's about 73%. Okay, so about 73% of the American population consumes between 4 and 7 gallons of ice cream per year. Okay. So for example 2, okay, it's a similar kind of problem. So I would invite you actually to pause the video here, now the problem's there, and try it on your own first and see if you can work it through. Okay, maybe work with a partner and do that first. Okay, and then when you're ready, come back and go through the solution. But I'll just read it out here. Peanut butter cups measure about 5 centimeters in diameter. A cup is considered to be bad if it's more than 0.1 centimeter off the intended size. The machine that makes them at the factory produces a mean size of 4.99 centimeters with a standard deviation of 0.05 centimeters. what percent of the cups will be deemed acceptable? Okay, so how many of the cups that come out of the machine are actually fit to go in the package? So again, I would invite you to maybe pause here, try it on your own, and then come back and watch the solution. Okay, let's resume now. So first thing we should probably look up, or sorry, write down, okay, right, what is considered to be acceptable? Okay, so it says that they're supposed to be 5 centimeters and they can't be more than 0.1 centimeter off. Okay, so my acceptable range would be then from 4.9 to 5.1. Okay, and now we'll go to our curve. So the mean is just a tiny bit under 5. Okay, 4.99. And I'm looking for between 4.9, which is about 2 deviations away, so somewhere over here. Okay, and 5.1, which again would be about the same in the other direction. Okay, so now it's going to be the same procedure as what we had on the previous page. We'll need to do a Z-score for each one. Okay, so for Z1, we're going to have our target score is 4.9. Okay, our mean is 4.99. Okay, and our standard deviation for the machine was 0.05, so 0.05. So for our first Z score, when we worked it all through, I get negative 1.8. And if I looked it up in the table, negative 1.8 is 0.0359. Okay, and now we'll do the same thing again for the other score. Z2. So I have 5.1 minus 4.99, and then divide by 0.05, and that is 2.2. Okay, and again going to our table, that is 0.9861. Okay, so finally, we'll subtract those two values. So I have 0.9861 minus 0.0359. Okay, which is 0.9502. Okay, so again, that is right about 95%. Okay, which I suppose shouldn't be too surprising here, because right, 0.5 as our standard, 0.05 is our standard deviation. The limit on this is 0.1, which is basically 2 standard deviations in both directions. Okay, so yeah, that means a little off center from this, but yeah, essentially it's 2 deviations, so that's 95% of the cups. Okay, so those would be acceptable, and the remaining 5%, I don't know, would be crushed up and sold to Dairy Queen or something like that. Okay, for our last example, going in a slightly different direction. Okay, in a recently held math contest, the top 10% of students scored a 75 or higher, and the top 5% were 78 or higher. What were the mean and standard deviation of this contest? Okay, so again, I would invite you to pause here for a sec and maybe try to set this up yourself, and when you're ready, come back and have a look. I Okay, so let's continue. I I don't know anything about where my mean is right now, but I'll just draw it on, right? It's somewhere there. Okay. But I'll put these on. So top 10 and top 5 are going to be way up along here. So 78 is somewhere up here, and a 75 is probably not too far behind it. Okay. So what were the mean standard deviation of this contest? Okay. So one way we can approach this is kind of work through the system backwards. Okay. I'm interested in this range in between them. Sorry, no, I'm not. But same idea. I know where this is. I can use my Z-scores to get an idea where these different values are. Okay. So for example, for 75, okay, if I start to try to fill that in, okay, 75 minus my mean over my standard deviation. Okay, and I can figure out the Z-score because it told me that was top 10%. So as you might recall from the other day, the top 10% is equivalent to being right above the bottom 90%. So I need to go into my Z-score table and try to find the closest possible thing to 90%. Okay, so we'll have a little peruse in here. And okay, it looks like right here. 0.8997. Okay, is only 0.0003 off from that. Okay, so that is a Z-score of 1.28. Okay, so I have 1.28 is equal to 75 minus mean, okay, over standard deviation. Okay, and that's about all I can do with that right now. But I can do it again for the 78. Okay, so I have my Z2 equals 78 minus the mean over the standard deviation. Okay, and I can look up the Z-score that corresponds to top 5%. Okay, which would be the same as saying 95%. So let's go back to our table and find what's closest to 95%. So we have 94, 94. Okay, right in here. And uh-oh, I have a tie. I have 0.9495, which is 0.0005 less. And I have 9505, which is 0.0005 more. This is a little problematic, right? Which one should I pick? Well, one way we can get around this is say, well, because it's perfectly balanced, then realistically, the score of 95% should be exactly halfway in between there. So the corresponding Z-scores are 1.64 and 1.65. So why don't we call this 1.645. Okay, and actually, you can do that with any pair of numbers on here. It's a process called interpolation, which if you would like me to show it to you, I can do that on Monday or Tuesday. But yeah, I know it's exactly in between. Should be roughly halfway in between, so we'll go with that. Okay, but now what? I've got two equations, and I'm missing two things in each one of them. Okay, what should I do? But hold on a sec. Let's dig back to starting in grade 10. I have two equations that each have two unknowns in them. So this is basically solving a linear system, right? I can do this. I just need to do some rearranging, so I can either do substitution or elimination and figure out what these are. Okay, so the fastest route, I think, is substitution. Okay, I'm going to rearrange each equation where I just switch, right, the standard deviation and this number. I multiply by sigma to bring it up, and I divide by this number to bring it back down. So I'm going to have sigma equals 0.75 minus x over 1.28. Okay, and on my other side, when I do the same switch, I'm going to have sigma equals 78 minus x bar over 1.645. Okay, so now I have two equations that say sigma equals, which means that those two things are equal to each other. So I can substitute one expression for sigma into the other expression, and I get this equation. 75 minus x bar over 1.28 equals 78 minus x bar over 1.645. All right, and now it's some equation solving. So to clear the denominators, I'm going to cross multiply. So I need to multiply this by 1.645 and multiply this side by 1.28. So 75 times. So when I multiply this side by 1.645, I'm going to get 123.375 minus 1.645 x bar equals 99.84 minus 1.28 x bar. Okay, now I'd like to get my terms with x together. So I'm going to bring this x term to that side and this constant to that side. So I'm going to have 123.375 minus 99.84 equals 1.645 x bar minus 1.28 x bar. So 123.375 minus 99.84. That is equal to 23.535 and 1 point. Oh, no, that's okay. Okay, 0.365 x bar. Okay, next step would be to divide this by 0.365. So when I do that, I get about 64.5. Okay, so the mean score on this math contest was 64.5. Okay, finally, I'm going to go back to one of my original expressions for sigma. Maybe say this one. Okay, and then substitute in my value for x bar. So I got 64.5, and then use that to solve for sigma. And when we do that, we get about 8.2. Okay, so again, the mean of this math contest was 64.5 with a standard deviation of about 8 points. Okay, 8.2. And that's it. Okay, so that's about as complex as we go with Z scores. Okay, so for practice, okay, starting same section as yesterday, so page 187, and some questions here, number 9, 11, 12, and 14 through 19. Okay, would be some good practice for this. Okay, or of course, you could continue to work on your assignment. That would also be a very good use of your time. All right. Thanks for watching, and I hope to see you on Monday.